Hi students, we will start with parametric equations. In order to introduce this parametric equation, we want some preliminaries. As you know, the counting number system, that is the natural number system, that is equal to set 1, 2, 3, etc. If you plot it on a line, the positions will be like this. 1, 2, 3, etc. And if you'll add a 0 here, we'll get the whole number system. And if we'll add negative numbers, etc. in this line, we will get the set of the whole integer system. And you know, in between the numbers, they are equally spaced. There are so many points in between the 1 and 2, 2 and 3, 0 and 1, minus 1 to 0, etc. Therefore, we can squeeze some fractions inside that. Fractions means the rational numbers. Q is equal to set of all of the numbers of the form P by Q, where Q not equal to 0, where P and Q are integers. In that sense, we can squeeze 1 by 2 here, 3 by 2 here, and so on. In negative side also, we can add some numbers in between. But this line, on this line, still there will be some points. Okay. For that, we are familiar with root 2. And you know how you will find a definite place for root 2 on the real line? By using Pythagoras theorem and all in school level. And it is not an irrational number. And usually rational numbers are denoted by Q dash. And rationals together with irrationals, we will get the real number system. And this Z becomes real number system. Actually, this real number system is actually dense in the sense that for every real number, you have a definite place in this line. And if you will take any point here, that will represent a real number which is greater than 3. Okay, these are the basics about real number system. As far as mathematics students are concerned, this real number system plays a vital role in their studies. They will learn this real number system in detail in further future semesters. Now, suppose we have the real number system R, and if I will draw a line which is perpendicular to this R, then terminology will change. This becomes x-axis. And this becomes y-axis. Y-axis. Both are real lines. Both are real lines. Usually, mathematicians call this plane is R2 plane. R2 plane. Okay. R2 plane. R cross R, that is R2. Any point on this plane will be P, and it is having two coordinates P, X, Y. That will be obtained by drawing a perpendicular to the x-axis. This OM is X, the foot of the perpendicular M, therefore OM is X and MP is Y. Thus, any point in the system or this plane, there is a representation like this P, X, Y. Then it will be OM is X, MP is Y. And as you know, this X is known as, X coordinate of that point is known as abscissa, and Y coordinate is known as ordinate. And this system is known as Cartesian system. Cartesian system. Therefore, all things are familiar to you. We come across these preliminaries, that is Cartesian system. Now, in this Cartesian system, every equation, that is the relationship between the variables x and y. For example, consider y equal to x, that is y is a function of x. Simply the identity mapping y equal to x. You can draw this function on the curve, on the Cartesian system like this. As you know, y equal to x is a first degree equation, therefore it will always represent a straight line. For drawing a straight line, we need only 2 points. When x equal to 0 implies y equal to 0, that is 0, 0 is a point. Similarly, 1, 1 is a point. Then we have 0, 0, that is origin, 0, 0, and 1, 1 will be here, 1, 1. Now, taking a scale, we will draw a straight line which is passing through the origin. Okay. And another one, y equal to x square. Y equal to x square. That figure is also familiar to you, y equal to x square. It is nothing but our familiar parabola is open towards upwards. This is y equal to x square. These are some examples in Cartesian system, equations in examples in Cartesian system. We want some more example. For example, we have x square plus y square equal to a square. X square plus y square equal to a square. There is a remarkable difference between these two equations and this equation. Here y equal to f of x, that is y equal to x. Here also y equal to f of x, that is y equal to x square. Here it is both are involved. Such a type of equations are known as implicit functions. Therefore, a simple implicit function is x square plus y square equal to a square. Further, you are familiar with y square equal to 4ax, the parabola you studied in +2 classes. Here also we cannot find the explicit value of y. It is not y equal to f of x, of the form y equal to f of x. Or ellipse, you are familiar, x square by a square plus y square by b square equal to 1. Here also we cannot take y as a single entity, therefore this is an example for implicit function. And another one, you are familiar with the hyperbola x square by a square minus y square by b square equal to 1. Here also we cannot write y explicitly. Therefore, these two functions are explicit functions and these all functions are implicit functions. Therefore, if we will try to find the position of the curve at a particular number, when x equal to 1, we will get y equal to 1, therefore the position is like this. But here and here also, if we will put x equal to 1, then y also equal to 1, therefore it will go through 1, 1, or x equal to 0, y equal to 0, therefore the position is here. Explicitly, we can find the value of x and y, ordered by x and y. But here, the x square plus y square equal to a square, we cannot explicitly find the value of y directly. Therefore, we will thinking about a new system, or is there any relationship between x and y with an external body that we are going to study. We can start this with this equation also, y equal to x. I will take both are equal and I will take x equal to t, y equal to t, x equal to t, y, then y also equal to t. Here, when I put x equal to t, y equal to t square. And here, when x equal to a cos theta, y equal to a sin theta, x equal to a cos theta, y equal to a sin theta, you can substitute x equal to a cos theta and y equal to a sin theta here. We will get x square means a square cos square theta plus y square means a square sin square theta. That is equal to a square into cos square theta plus sin square theta. And that you know, that identity you know, that is 1, therefore a square. Therefore we have x square plus y square equal to x square plus y square equal to a square. Therefore we have a representation of x and y in terms of theta. Here also we have put x equal to a cos theta, y equal to b sin theta. On substituting these x and y in this equation, we will get x square means a square cos square theta by a square plus b square sin square theta by b square equal to a square x square get cancelled, b square get cancelled, cos square theta plus sin square theta is equal to 1. Further, in this example, put x equal to a sec theta, y equal to b tan theta. Okay, if you substitute x equal to a sec theta here, we have a square c square theta by a square, that cancelled, we will get c square theta. Here we substitute y equal to b tan theta, therefore b square tan square theta by b square, that is tan square theta, c square theta minus tan square theta, that is equal to 1. Therefore we have a new form, that is in the first equation both x equal to t, y equal to t. The second one x equal to t, y equal to t square. The third one x equal to a cos theta, y equal to a sin theta, and so on. Look at these representations. X and y are related to t. X and y again, the second one, related to t. X and y related to theta. Therefore, we'll call this x is a function of t, that is f of t, and y is also a function of t, let us call it as g of t. And then we say that this representation is the parametric representation of equations. This representation is known as the parametric representation of equations, where t is called the parameter. T is the parameter. T is the parameter, and t, there will be a domain for t. I'll call it as I. Notation will be I. Therefore, t belongs to I. Okay. Therefore, when we substitute the value of t here, we get the values of x and y. When we substitute value of t here, we will get x and y. Here, usually we will use t notation, but theta also is a notation. Okay, otherwise we can write it as x equal to a cos t, y equal to a sin t, and so on. Therefore, this is the parametric representation. Therefore, finally, the definition of parametric equation is, that is of the form x equal to a function of t, y equal to a function of t, both f and g are continuous functions of t, and t ranges over the interval I. It may be 0 to 1, interval may be 0 to 1, closed interval 0, 1, or 0 to 2 pi, or minus 2 to plus 2, and so on. Okay. Therefore, these are the examples for parametric representations. In polar Cartesian system, we have the coordinates x and y, that is any point will be represented by xy, and we have the function relationship between x and y equal to f of x. Now, as we know, x and y will be related with one entity. That entity is known as the parameter. Therefore, here t is the parameter. Now we are trying to draw the figures by using this parametric equations. For example, suppose you are asked to draw the curve with the parametric equation x equal to t square minus 4 and y equal to 2t, where minus 1 less than or equal to t less than or equal to 2. Minus 1 less than or equal to t less than or equal to 2. Here the I equal to, the interval I is equal to minus 1, 2. Therefore, t ranges between minus 1 to 2. In order to draw the curve of this equation, we will find the function values at different points between minus 1 and 2 for t. For that, we will start with t equal to minus 1 implies x is equal to minus 1 square minus 4, that is equal to 1 minus 4, that is equal to minus 3, and y equal to 2 into minus 1, that is equal to minus 2. Therefore, our point xy equal to minus 3 comma minus 2. As far as this interval is concerned, the initial point of the curve is minus 2, minus 3, minus 2. Similarly, we will find another value, that is minus 1, then minus half, t equal to minus half. When we substitute t equal to minus half, implies x is equal to minus half square minus 4, that is equal to 1 by 4 minus 4, that is equal to 1 minus 16 by 4, that is equal to minus 15 by 4. Similarly, y equal to 2 into minus half, that is equal to minus 1. The corresponding point will be xy, becomes xy is minus 15 by 4 comma minus 1. And now when t equal to 0, x is equal to minus 4, y equal to 0, the corresponding point xy is equal to minus 4 comma 0. When t equal to 1, we will get x is equal to 1 minus 4, that is minus 3, y equal to 2 into 1, that is 2. The point is minus 3 comma 2. And when t equal to 2, x is equal to 4 minus 4, that is 0, y equal to 2 into 2, that is 4. The point will becomes 0, 4. Thus we have 5 points: t equal to minus 1, t equal to minus 1 by 2, t equal to 0, t equal to 1, and t equal to 2. And you know, this point is the initial point, that is minus 3, minus 2. And the terminal will be at t equal to 2. At t equal to 2, the terminal point is 0, 4. Using this, we will draw the figure. 2, 3, etc. Here it is minus 1, minus 2, minus 3, etc. 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, etc. The first part, the point is minus 3, minus 2. X is minus 3, y is minus 2. Therefore, this point becomes this one. And the next one, t equal to minus half. is x equal to minus 3, yes. When t equal to minus half, we have minus 15 by 4 minus 1. Okay, y is minus 1. This is 15 by 4, that is more than 3, therefore point will be like this. When t equal to half, therefore minus 1, therefore this point will be here. When t equal to 0, we will have minus 4, 0. This will be minus 4, this will be the point. So the next one, t equal to 1, the point will becomes minus 1, comma 2 here. And when t equal to 2, we have 0, 4, that is 0 for this point. Thus, we can draw the figure from this part. Okay. So this is the curve x equal to t square minus 4 and y equal to 2t between minus 1 to 2. The initial point is this one, that is, as you know, minus 3 comma minus 2, and the terminal point is 0, 4. And the direction of the curve is starting from minus 3 to minus 3 minus 2 to going upwards, this one. And you know, this equation, that is x equal to t square minus 4, y equal to 2t, can be converted into the Cartesian equation by replacing this or eliminating t between x and y. As you know, y equal to 2t, therefore t equal to y by 2. Substitute that y by 2 here, we will get x is equal to y by 2 square minus 4, that is y square by 4 minus 4. That is x is equal to y square by 4 minus 4, or 4x is equal to y square minus 16, or y square equal to 4x plus 16. 4x plus 16, or 4 into x plus 4. You are familiar with the parabola y square equal to 4ax. You are familiar with the parabola y square equal to 4ax. Its vertex is 0, 0. Vertex is 0, 0. The figure will be like this. Y square equal to 4ax is having, where a is a positive number. This will be the figure of the parabola y square equal to 4ax. You are familiar in plus 2 classes. 0, 0 is the vertex. 0, 0 is the vertex. In a similar fashion, we have the equation of the form y square equal to 4 into x plus 4. Only difference is, instead of x, we have x plus 4. Instead of 4a, we have 4. 4a equal to 4, therefore a equal to 1. Therefore, this can be written as 4 into 1 into x plus 4. Okay. Therefore, this is of the form y square equal to some 4x, where capital X is equal to x plus 4. And you know this y square equal to 4ax, vertex is 0, 0. There we put x equal to 0, y equal to 0, they will get 0, 0. Here also, we will put y equal to 0, we will get y equal to 0. There is no change. There is a change for capital X. X plus 4 equal to 0. Therefore, x is equal to minus 4. Therefore, its vertex becomes at the point minus 4, comma 0. This is the vertex of this new parabola y square equal to 4 into x plus 4. In a similar fashion, we can draw a different curves by using the given parametric representation. Another example, we already said that x equal to t, x equal to t, y equal to t square, then this y equal to x equal to t therefore is equal to x square. This is the conversion from parametric to Cartesian system. Another examples already we found, x equal to a cos theta, y equal to b sin theta, x square by a square plus y square by b square equal to cos square theta plus sin square theta equal to 1. Therefore, x square by a square plus y square by b square equal to 1. That is the parametric, this is the Cartesian equation of x equal to a cos theta, y equal to b sin theta. And I already mentioned this ellipse, parabola, hyperbola, and so on. Now, we will go through some examples. Another example. Example suggests that x equal to x equal to 2t plus 1, y equal to t minus 3. Immediately you can convert it into Cartesian format, t equal to y plus 3. Then this equation becomes x equal to 2 into y plus 3 plus 1, that is equal to 2y plus 6 plus 1 or 2y plus 7. Therefore, x is equal to 2y plus 7 is the corresponding Cartesian equation. Here also we can plot this one by using by giving different values for t. And you know this. Another example, x equal t equal to x equal to t minus 2, y equal to 2t minus 1, and the range of t is minus 1 less than or equal to t less than or equal to 5, less than or equal to 5. What will be the initial point? Initial point is obtained by when t equal to minus 1. T equal to minus 1 implies x is equal to minus 1 minus 2, that is minus 3, and y equal to 2 into minus 1, that is minus 3, minus 2 minus 1, that is minus 3. Therefore, the initial point becomes minus 3, minus 3. And the final point will be, terminal point will be obtained from t equal to 5. When t equal to 5, we will get x is equal to 5 minus 2, that is 3, y equal to 2 into 5 minus 1, that is equal to 10 minus 1, that is 9. The terminal point becomes 3, 9, and so on. The conversion to Cartesian form, as you know, t equal to x plus 2 from here, then y equal to 2 into x plus 2 minus 1, that is equal to 2x plus 4 minus 1, that is 2x plus 3. Therefore, the corresponding Cartesian equation is 2x plus 3. We can draw this one by using different values for t. We have initial and terminal points. Between that, we can have a value at t equal to 0, t equal to 1, t equal to 2, t equal to 3, and so on. We can draw the figure by using, actually it will be a straight line, very easy to calculate. Another example is x equal to root t, y equal to 9 minus t. Range becomes 0 to 3. Anyway, what about the change? That is x square equal to t. Therefore, y equal to 9 minus, instead of t we have x square. Therefore, we get y equal to minus x square plus 9 is the corresponding Cartesian equation. Now, so far we came across some examples. Now, the application of this parametric equation is, immediate application is, it is in calculus, differential calculus. We have x is a function of t, y is a function of t, x is a function of t, y is a function of t, where f and g are continuous functions of t. Usually, differentiation between x and y. The Cartesian format of our equation is y is a function of x. And you know, instead of y, we have g of t. G of t equal to f of, instead of x, we have x of f of t. F of t. Now, differentiating this entity, we will get g dash t equal to, here is a function of, we have to use function of function rule. This is f dash of f of t into small f dash t. That is, or g dash t divided by f dash t equal to f dash of f of t, or f dash f of t equal to g dash t divided by f dash t. But you know, f dash of f of t means x, f dash of x is equal to g dash t divided by f dash t. This is an important formula. This is the parametric differentiation. Therefore, in order to differentiate y equal to f of x with respect to x, first we will differentiate this gt with respect to t, that is g dash t divided by f of t with respect to t. Example, suppose x equal to a cos t, a cos theta, y equal to b sin theta. What about dy by dx? That is the question, dy by dx. Here it is nothing but dy by dt divided by dx by dt. This is already familiar to you. That is equal to, as you know, y equal to b sin, theta. Y equal to b sin theta, therefore dy by d theta is equal to b cos theta divided by dx by d theta. X equal to a cos theta, therefore what is the derivative of a cos theta? That is a into minus sin theta is equal to minus b by a cot theta is the derivative of x equal to a cos theta, y equal to b sin theta. Another one is x equal to at square, y equal to 2at, another parametric representation. What will be dy by dx is equal to dy by dt divided by dx by dt, that is equal to dy by dt, you know, 2a divided by dx by dt means a into 2t, 2 get cancelled, a 2 get cancelled, we will get the values 1 by 2 and so on. Therefore, these things are familiar to you in +2 classes. Therefore, that is the immediate application of this parametric equations.